Okay, so this is the video that will show you how to do the questions for your second assignment, which is this one right here. Fairly short assignment. Most of the properties here are things you learned from last year, combined with what we just learned in the last section. A couple of new theorems, really only one new theorem that we're going to look at, and then what will be new for you this year is this theorem right here that I'm about to go over, and then the fact that we're going to combine it with parallel lines and a couple of other theorems all in one kind of question. So this is non-adjacent interior angles. It's a lot of words, a wordy theorem for something that's not actually that difficult. A little note up here, the theorem sheet that I talked about in the previous video, and that's there with your notes. This theorem would have been called EATT, or abbreviated EATT, the exterior angle of a triangle theorem. And all this is telling you is that if I looked at this angle A and this angle B, you added those two angles together, that total would be the same as this angle here. So this is two interior angles that aren't next to. So it's non-adjacent. Adjacent means next to. So non-adjacent means not next to. So two angles on the inside of the triangle. So the two that aren't next to the one that I'm interested in. So these two interior non-adjacent angles will total the same as the exterior angle. So that's the reason this one was called the exterior angle triangle theorem, because it referred to the outside angle being the same as the two interior angles that are away from the one that's given. So that's all there is to that one. Really quickly, again, these notes are available with it, so it's a PDF of exactly the slides that I'm going through. It should be loaded up there. You can print them off. Here's another summary. There's the one I just talked about. Here's one from last year. Most times you guys already remember this. This is one of the things you seem to keep hold of from year to year, that all three angles on the inside of a triangle have to total 180 degrees. So I'm not going to go over that again. It's here in your notes to be printed off. So with that being said, let's go through a couple of examples. And if you've got these printed off as notes, that's great. You just follow along. If you don't, then you can copy it down in your notes and just pause it. Just pause the video while you copy it down. And then you can have time to just sit back and watch me do it. That would be the easier way to do it. All right. So here's my exterior angle. And it's fairly obvious with a triangle. Here's my exterior one right here. It's not on the inside, it's the only exterior angle. So that's saying that this exterior angle has to be the same as the two non-adjacent angles added together. So that means this one and this one right here, angle Z, have to total 101 degrees. So all you have to do in your head mentally is go 101 subtract 64, leaves me with what I need to put in with Z. So that's going to leave you with 37 degrees. And then over here, so what else did they ask for? They asked for angle Y, X, Z, so Y, X, Z. So they asked for this one here as well. So they asked for this one, angle Y, X, Z. The reason they specify this with 3, Y, X, Z, rather than just calling an angle X, in this particular case, angle X could refer to the 101 degrees, this one on the inside right here, or 180 degrees on the other side of that straight line. So you have to specify that it's Y, X, Z that you're actually referring to this angle right here. We've got a nice straight line right here, so the total is 180 degrees, so that means that, let's just fill this in, this one has to be 79 degrees. When use the supplementary angle theorem for that. The other thing you could have done at this point is you would have said, well, okay, I've got 2 out of the 3 angles inside that triangle. I know that the total of all 3 has to be 180. So you can go 180 minus the 2 that I already have, and that would have given you 79 degrees as well. And if you had to use that theorem, all 3 angles inside of the triangle adding up to 180 degrees, that would be the angle sum of the triangle theorem, which is abbreviated like that. All right, next one. They want angle A, so this one up here, and they want DCE, so DCE, this one right here. So let's start with angle A. Once again, I have an exterior angle that has to be the same as these 2 interior angles. Now, just to briefly mention here, if I cut this off like this, then this looks exactly like this problem over here. So it makes it a little less confusing. They extended this line, which makes it a little more confusing. But when you're doing this, you can just use your hand or a ruler to cover up any lines that you want. That makes the diagram a little easier. And so if I cover that up, it's easy to see that this is 134 is the exterior angle for these 2 added together. So if I go 134 minus 49 degrees, okay, so a little bit of mental math, let's go 134 minus 50 degrees instead. That leaves me with 84, so it's actually 85 degrees. And so angle A has to be 85 degrees. We use the exterior angle, the triangle theorem there. Now let's do DCE. So again, they're looking for this angle right here. I would say, oh, there's a nice straight line. I have 134 degrees right here. So 180 minus 34 leaves me with 46 degrees. So that was angle DCE. And we use the supplementary angle theorem for that. All right, so that was it. Just a couple of really quick examples there. You should be able to go to this assignment. If you're working on this one now, then you should have assignment 1 into me already. And I'll be mentioning in-class deadlines for these things. So it's not going to be completely self-paced. If you finish early, that's great. But there are deadlines. You have to have them in by a certain point so we can move on to the next section as an entire class.